Wow, I'm so excited. Llama 3 is finally here. Today, Meta Platforms, the parent of Facebook, released the most powerful version of its Llama AI model yet, Llama 3. Today, we're going to take a look at Meta's Llama 3 announcement, try some initial tests using the model, and then compare Llama 3 benchmarks with Meta's predecessors, as well as some competitive models. And soon, I'll be releasing a more in-depth video that runs through my testing rubric. And we'll also have a feature on coding and fine-tuning. So if you don't want to miss out on that, don't forget to subscribe. So with that, let's jump in. This is the third iteration of Llama models from Meta, and of course, it's open weights. So Meta continues its tradition of democratizing access with their open platform, where developers can work with AI models, tools, resources, and have tremendous influence over the current gigantic wave of innovation that's transforming the AI space right now. Llama 3 aims to compete with the most recent advances from OpenAI, Anthropic, Google, xAI, and Databricks. Llama 2 was a big improvement over the first iteration of Llama, and Llama 3 continues that pattern, with substantial performance improvement over Llama 2. This is the Llama 3 landing page. If you want to download the models and work with them yourself, go to llama.meta.com/llama3. Meta Llama 3 is available in 8 billion and 70 billion parameter models, instruction-tuned and pre-trained. The instruction-tuned models are best for assistant-like chats, whereas the pre-trained models are for general-purpose natural language generation tasks. For playing around with it, I recommend the instruction-tuned version. Click Get Started. In the sidebar, you'll see Getting the Models, and you can download the models from Meta directly. After accepting the license agreements, they'll send you a signed URL that gives you 24 hours to download the models. Or head over to Hugging Face. Or Kaggle. I'll put all these links in the description below for you. For now, we're going to do some quick tests on the model directly using Meta's chat client, which you see here. Go to meta.ai. You can get the link in the description below the video as well. For the first test, I'm going to ask Meta AI to write the game Breakout in Python. That was pretty good code generation speed. And it also tells us about the Pygame dependency that we have to install below. So I'll show you how to do those things. We're going to take this code, try it in VS Code, and see if it runs. So the first step is to create a project directory, which I did here, called Llama 3. And the next step is to create a virtual environment. The virtual environment will have our Python interpreter and any project dependencies. Python -m venv venv. What that will do is it will use the venv module to create a virtual environment in the venv directory. So now our Python interpreter lives in the venv virtual environment, but we have to activate this environment. So we source venv bin activate. Now you notice it modified the path and put this indicator that we're in a virtual environment. Next step is to install the Pygame module. And there we go, Pygame is installed. Now let's head over to VS Code and see if we can get the code to run. Okay, and we're here in VS Code with the code pasted in, and also the Python interpreter is showing at the bottom as 3.12.2, and we're going to give the code a run. Look at that. We've got the bricks, the ball's doing its thing, the paddle, and all the motion looks right. Let's see what happens when I miss. Do I get another ball? There it is, a random ball. Let's see what happens when we finish all the bricks. Okay, no victory, no score, but that's okay, I'll take it. This looks like a pass to me. Good job, Llama 3. Now let's ask it to generate an image. Create an image of a flying pig. And look at that, it created it so fast I didn't even have to hit the button to upload for it to create the image. And it actually starts to create the image while you're still typing. Create an image of a futuristic flying machine. Cool, not bad. Now watch this as I change the words. It updates instantly. It's pretty amazing. Watch. Dog, cat, pig. That's amazing. It's generating these images immediately upon change to the prompt. So I'm really impressed with that ability. Those are the only tests we're going to do right now. I'll be doing more comprehensive testing coming up in future videos, but for now, let's look more closely at the model. So I'm looking at the model card for Llama 3 in the GitHub repo. Meta trained both the models released today on two custom-built 24,000 GPU clusters. Meta CEO Mark Zuckerberg said that the company trained the 70B model with around 15 trillion tokens of data. That's more than the 12 trillion tokens used to train Databricks DBRX, which I was so impressed by and we covered in a previous video. And strikingly, throughout that process, the model never reached saturation. In other words, it never hit a wall in increasing capability. They pulled the plug to move on to train other models. So that in itself is amazing to hear, because performance achieved is excellent, and yet it didn't even top out. It says here that Llama 3 was pre-trained on over 15 trillion tokens of data from publicly available sources. The fine-tuning data includes publicly available instruction datasets, as well as over 10 million human annotated examples. And then they make a note here that neither the pre-training nor the fine-tuning datasets include meta user data. Let's check out how Llama 3 compares with its predecessor Llama 2 on the benchmarks in this model card. You'll notice that there's another model here listed, the 13B model, which we're not considering today. They didn't release that today. They did release Llama 3 8B and Llama 3 70B. So that's what we're looking at. These two columns in relation to the Llama 2 7B and the Llama 2 70B. So let's compare these two, which is the new model versus the last generation. And it handily beats all of the benchmarks across the board, Llama 3. And it's a 8 billion parameter model. So it's close to the 7 billion and beat all the benchmarks. And then we see the same phenomena over here. Llama 3 70B also beat out Llama 2 70B in every single benchmark. Turning to instruction-tuned models, check this out. So this is a dramatic improvement in 68.4 versus 34.1 Llama 3 to Llama 2, and that's a doubling of performance. Over here, outperforming on everything else. This one here, human eval 62 versus almost 8. That's a dramatic improvement. And then over here on GSM, 79.6 versus 25.7. And here another dramatic improvement, 30 on math versus 3.8. Now let's turn to the 70 billion parameter model. Let's look at GPQA. We see that it's doubling the previous performance, 39.5 versus 21. Over here, human eval, another dramatic move. 81.7 on the Llama 3 score for 70 billion versus 25.6. This one is very high, this number, GSM, 93 versus previous 57. And over here, math, almost a 5 times improvement with 50.4 versus 11.6. So dramatic results between Llama 2 and Llama 3. I want to talk about responsibility and safety for a moment. There's a lot of emphasis in this Llama 3 model on safety. I want to get into that. We believe that an open approach to AI leads to better, safer products, faster innovation, and a bigger overall market. We're committed to responsible AI development and took a series of steps to limit misuse and harm and support the open source community. Meta says, we are making available what we believe to be the industry's first and most comprehensive set of open source cybersecurity safety evaluations for large language models. CyberSec Eval 2 expands on its predecessor by measuring an LLM susceptibility to prompt injection, automated offensive cybersecurity capabilities, and propensity to abuse a code interpreter, in addition to the existing evaluations for insecure coding practices and cyber attack helpfulness. So that's really interesting. It's in this chart over here, the dimensions that they're making available. Meta points to this white paper, CyberSec Eval 2, a wide-ranging cybersecurity evaluation suite for large language models. Large language models introduce new security risks, but there are few comprehensive evaluation suites to measure and reduce these risks. We present CyberSec Eval 2, a novel benchmark to quantify LLM security risks and capabilities. We introduced 2 new areas for testing, prompt injection and code interpreter abuse. And this matrix gives an overview of the CyberSec eval benchmarks. It's actually very interesting. If you look at this, find instances of insecure coding practices in open source code and see whether an LLM reproduces them when prompted to implement the same functionality. So that's what they're testing for. You can see how that would be unsafe if it was able to produce the same vulnerabilities based on its training data. And then cyber attack helpfulness. What's that? Generate a large set of prompts that ask an LLM to carry out cyber attacks, and then use an LLM judge to evaluate whether the LLM under test complies. Very interesting. This one, prompt injection. Handcraft system prompts that define LLM behavioral rules, and then use a judge LLM to see if the test prompt injections induce violations of these rules. So very interesting. This is a really responsible approach to test out the model to see if it's subject to these vulnerabilities. Of course, the risk is that if any of these vulnerabilities are in the training data, then it will look to be more safe than it might actually be. Vulnerability identification and exploitation. Randomly synthesize programs and then measure LLM's ability to exploit them. And then finally, code interpreter abuse. Create a set of prompts that ask an LLM to abuse a code interpreter, and then use an LLM judge to determine whether the LLM complied. So very interesting, very responsible approach to looking at the safety of a model. Meta says Llama 3 models will soon be available on AWS, Databricks, Google Cloud, Hugging Face, Kaggle, IBM Watson X, Microsoft Azure, NVIDIA NIM, and Snowflake, and with support from hardware platforms offered by AMD, AWS, Dell, Intel, NVIDIA, and Qualcomm. We're dedicated to developing Llama 3 in a responsible way, and we're offering various resources to help others use it responsibly as well. This includes introducing new trust and safety tools with Llama Guard 2, Code Shield, and CyberSec Eval 2. In the coming months, we expect to introduce new capabilities, longer context windows, additional model sizes, and enhanced performance. And we'll share the Llama 3 research paper. With Llama 3, we set out to build the best open models that are on par with the best proprietary models available today. Think OpenAI, Gemini, Anthropic. We wanted to address developer feedback to increase the overall helpfulness of Llama 3, and we're doing so while continuing to play a leading role in responsible use and deployment of LLMs. So the reason they said that is because models can become unhelpful if you have a lot of false refusals. And what that means is that if you're trying to look for vulnerabilities and then avoid answering those kinds of prompts, that could backfire if a prompt is innocuous and then you end up refusing the user. That makes it unhelpful. So that's why they made that comment here. We are embracing the open source ethos of releasing early and often to enable the community to get access to these models while they are still in development. And that's great. It's fantastic. The sooner we can get it, the better. And also, it's going to create pressure on all of those closed source models as Meta releases more and better open source models. And Meta makes this claim: thanks to improvements in pre-training and post-training, our pre-trained and instruction fine-tuned models are the best models existing today at the 8B and 70B parameter scale. Improvements in our post-training procedures substantially reduced false refusal rates, improved alignment, and increased diversity in model responses. We also saw greatly improved capabilities like reasoning, code generation, and instruction following making Llama 3 more steerable. So here we have some comparison charts against Meta's competitors. Llama 3 8B is being compared against Google's Gemma 7B and Mistral's 7B Instruct. And as we look at these dimensions, we see that it wins on every single dimension, but the ones that are the most dramatic are GPQA with 34.2 for Llama 3, Gemma with 21.4, and Mistral with 26.3. Human eval is very dramatic with 62.2 versus Gemma at 30.5 and Mistral at 36.6. We also have a dramatic effect on GSM, 79.6 for Llama 3 versus 30.6 and 39.9 for the competitors. And math is also pretty dramatic. 30 for Llama 3 versus 12.2 for Gemma and 11 for Mistral. So that's quite dramatic performance by Meta Llama 3 8B. Now turning to the chart on the right with Meta Llama 3 70B, it's interestingly being compared against Gemini Pro 1.5 and Claude 3 Sonnet. Sonnet is not the leading model from Anthropic. It's actually the middle model, Haiku, Sonnet, and Opus. And Opus has the market-leading evaluation benchmarks. But looking at this comparison, we see that all of these benchmarks are at least in the same ballpark as compared to the Llama 3 8B model, where there's dramatic outperformance. I hope this video gave you a good first look at Llama 3, and I'll be back with more videos to test out the model more thoroughly, and as promised, coding and fine-tuning. To check out Llama 3 for yourself, I've dropped the links in the description below. What do you think about the model? Let me know in the comments. I'd love to hear your thoughts. And if you like this kind of content and don't want to miss out on any important advances, don't forget to like and subscribe. I'm Scott Ingram, and thanks for watching.